Hi everyone. Today we'll discuss D'Alembert ratio test or simply ratio test. What the statement? The summation un is a positive term series, then limit n tends to infinity un by un plus 1 equal to L. If L is greater than 1, the series is convergent. If L is less than 1, the series is divergent. If L equal to 1, the test fails. So convergent means greater than 1, divergent means less than 1. You see in some books they have written un1 un plus 1 by un. If it is like that, then L is less than 1 convergent. You see, for this case L is less than 1 convergent, L is greater than 1 divergent, equal to 1 test fail. So but I am going by un plus 1, so I will be following this thing. Okay, so no need for confusion, please. You have to be clear when we are doing math. So we'll do some examples. It will be clear for us. So let me go with the problem number 1. Test for the convergence of the series n square by factorial n. The question will be in the exam, it will be a test for convergence of the series. Convergence of the series. Series summation it will give. So our un is n square by n factorial. What will be un plus 1? Whenever n is there, you have to write n plus 1. Wherever n is there, you have to write n plus 1. Now we got this thing. Now what we have to do? Un by un plus 1. What is un? N square by factorial n plus 1 means if you divide, numerator become denominator. So n plus 1 by n plus 1 whole square. So this will be n square by n plus 1. Take these to one side. N plus 1 can be written as n plus 1 into n factorial divided by n factorial. Divided by n factorial. So this n factorial getting cancelled and this n plus 1 the power getting cancelled. So we are left with n square by n plus. So if we divide by n square denominator and numerator, this will be 1 by n plus 1 by n square. This is un by un plus un by un plus 1. Now apply the limit n tends to infinity both the sides. As n tends to infinity, 1 by n tends to 0. As n tends to infinity, 1 by n tends to 0. So 1 by 0 is infinity. Infinity is greater than 1. Greater than 1 means, for this case, greater than 1 means convergent. Therefore, summation un is convergent. How can you able to say? We are able to say by D'Alembert test or ratio test. One more example. One more example. Suppose one more example we'll go. 2 to the power of n into n factorial by n to the power of n. Problem is this, un equal to 2 to the power of n factorial by n to the power of n. So what will be un plus 1? Wherever n is there, we are writing n plus 1. So n plus 1, this is n plus 1 whole to the power of n plus 1. So what we are doing, un by un plus 1. What is our un? 2 to the power of n into n factorial by n to the power of n. This will go in the numerator, n plus 1 to the power of n plus 1 by 2 to the power of n plus 1 into n plus 1 factorial. So what we are doing? 2 to the power of n, sir. This is 2 to the power of n factorial, n to the power of n. This can be written as this can be written as 2 to the power of n into 2, and this can be written as n into n plus 1. n into n plus 1. n into n plus 1. So this is n 2 to the power of n. This is guy. Oh my god, I am getting confused. 1 minute. So this is un. This will come to the numerator. N plus 1 whole to the power of n plus 1. This denominator n plus 1. 2n plus 1. n plus 1 factorial. Now the next step is 2 to the power of n factorial, n to the power of. This I can write as n plus 1 to the power of n into n plus 1 divided by 2 to the power of n into 2. This is n plus 1 into n factor. n plus 1 into n factor. So this is 2 to the power of n, 2 to the power of n getting cancelled. This is n plus 1. This is n plus 1 getting cancelled. This n factorial is getting cancelled. So we are left with, you see, be cool. When we are doing this type of problem, be cool, please. Don't rush. Please don't rush. Do slowly. 1 by 2 outside. Everything got cancels. N plus 1 by n whole to the power of n. This can be written as 1 by n, 1 plus 1 by n whole to the power of n. So un by, this is un plus. Apply the limit n tends to infinity. Both the sides. N tends to infinity. This is 1 by 2. Limit n tends to infinity. 1 plus 1 by n whole to the power of standard limit is e. So e, this is e by e, half of e. Half of e greater than 1, convergent. Therefore, summation un is convergent. Now, one more problem we'll go. Let me go one more problem. One by 1 into 2 into 3, 3 by 2 into 3 into 4, 5 by 3 into 4 into 5, so on. So it is a positive term series. Un equal to, it is an odd number, 1, 3, 5, so 2n minus 1. This is n into n plus 1 into n plus 2. Un. So what is un plus 1? Wherever n is there, you are writing n plus 1. So it will be n plus 1, n plus 2, n plus 3. And here in the place of n, you are writing, you see, 2 into n plus 1 minus 1. 2n plus 2 minus 1 is 2n minus 1. So now what we have to do, un by un plus 1. Un by un plus 1. So what is here un? 2n minus 1 by n into n plus 1, n plus 2. And this will be numerator. It will divided by, again, you see, this old class a by b is divided by c by d equal to a by b into d by c. This one. So n plus 1, n plus 2, n plus 3. This is 2n plus 1 it will become by 2n plus 1. So n plus 1, n plus 2 is getting cancelled. So we are left with 2n minus 1, 2n minus 1 by 2n plus 1 and n plus 3 by n. We are left with this. So this is from here. If you take 2n common, this is 1 by 2n, and this is 1 plus 1 by 2n. 2n you have taken common. From here, if you take n common, 1 plus 3 by n. 1 plus 3 by n. Now un by un plus. So limit n tends to infinity. Un by un plus 1. Apply limit n tends to infinity. As n tends to infinity, 1 by n tends to 0. 1 minus 0 is 1. As n tends to infinity, 1 by n equals. This is 1 into 1 equal to 1. So therefore answer is 1. Answer is 1 means summation un is L equal to 1. Test fail. So therefore test fail. D'Alembert test fails for this problem. We can't apply D'Alembert test. If you can't apply D'Alembert test means in the exam, if it comes, you can't write test fails. You have to solve. If test fails, then you have to apply Rabi test. I will make another video for Rabi test. I will not discuss anything about the Rabi here. So we will discuss Rabi test in another video. I will make another video for Rabi test. So what about this one more problem? Please see one more problem. So 5 by 2 plus 5, 5 square by 2 square plus 5, 5 cube by 2 cube plus 5, so on so on. Un is 5 to the power of n by 2 to the power of n plus 5. So what will be un plus 1? What will be un plus 1? Un plus 1 is 5 to the power of, wherever n is there, we are writing n plus 1. That's it, n plus 1. Un plus 1 will. Now what is un by un plus 1? 5 by n square plus 5, 5 to the power of n, and this will be 2 to the power of n plus 1 plus 5 by 5 to the power of n plus 1. So what I am doing is here 5 to the power of n, 5 to the power of 5 into n. This is 2 to the power of n plus 1 plus 5 divided by 2 to the power of n plus. This getting cancelled. So what we are doing here, so 1 by 5, this you are taking 2 to the power of 2 to the power of n plus 1 from the numerator. From the denominator 2 to the power of n. So this will be 1 plus 5 by 2 to the power of n. This is 2 plus, no, we have taken, so 1 plus 5 by 2 to the power of n plus. So this I want to write 2 to the power of n into 2. It's getting cancelled. This is 2 by 5. 2 by 5. Now apply the limit. Apply the limit. So apply the limit. So limit n tends to infinity un by un plus equal to limit n tends to infinity 1 plus 5 by 2n plus 1, 1 plus 5 by 2n. As n tends to infinity, 1 by n tends to 0. So answer is 2 by 5. 2 by 5 is less than 1. Less than 1 means divergent. So the given series summation un is divergent. How can you say divergent? How can you say the series is divergent? How can you say? By ratio test or D'Alembert test, whatever you want to call it. That's it. So few problems we have discussed about the D'Alembert test. Now I will go for the Rabi test. In another video, I will make another video to show whenever the test fail, D'Alembert test fails, we will go for the Rabi test. Okay. Thanks for watching. Please do subscribe my channel for more upcoming videos. Thanks once again.